Mysteries of the Cosmos, How Black Holes Bend Time and Space. The universe hides many secrets, but few are as baffling, powerful, and awe-inspiring as black holes. These cosmic giants challenge everything we know about reality, bending the rules of time and space themselves. What are black holes? How do they twist and warp the very fabric of the universe? And what hidden truths might they hold? Let's take a journey beyond the boundaries of what we think is possible, into the enigmatic world of black holes. Prepare to be amazed as we uncover the mysteries that lie in the depths of the cosmos. Black holes are not just objects in space, they are phenomena unlike anything else in the universe. Imagine a region in space where gravity is so strong that nothing, not even light, can escape its pull. This is a black hole. Black holes are born from chaos. When massive stars reach the end of their lives, they collapse under their own gravitational weight, creating a dense core packed so tightly that it forms a singularity, a point where normal physics breaks down. Surrounding this singularity is something called the event horizon, a boundary where escape becomes impossible. Once you pass this edge, you're lost forever. These cosmic entities exist in different forms, from stellar mass black holes, which are several times the size of our sun, to supermassive black holes that sit at the center of galaxies and weigh millions or even billions of times more. They may sound monstrous, but black holes are also key to understanding the universe and its natural balance. To fully grasp how black holes bend time and space, we need to understand the fabric of reality itself. Enter Albert Einstein and his groundbreaking theory of relativity. Einstein described the universe not as a static stage for objects to move around on, but as a malleable fabric called space-time, a tapestry where space and time are interwoven. Imagine space-time as a giant, stretched-out trampoline. If you place a bowling ball on the trampoline, it sinks into the surface, creating a dip. Smaller objects, like marbles, roll toward the ball, following the curve in the fabric. This is how gravity works. Massive objects warp space-time, and black holes, being incredibly dense, create the deepest bends of all. Black holes take this concept to an extreme. Their mass bends space-time so dramatically that it's as if the trampoline stretches into a funnel that just keeps going. This immense pull explains the mysterious properties of black holes, including their ability to trap even light itself. The warping of space around black holes is a spectacle of cosmic proportions. Gravity doesn't just pull objects closer to a black hole, it distorts the paths they take. Think of planets' orbits around the sun. Instead of traveling in straight lines, planets curve along the sun's gravitational well. Near black holes, this same bending becomes extreme. One of the most astonishing phenomena caused by black holes is gravitational lensing. Light, which typically travels in straight lines, bends around the intense gravity of a black hole. The result is a warped, magnified view of the universe behind it. Imagine looking at a distant galaxy through a funhouse mirror. This is what light does near a black hole, creating kaleidoscopic and mind-boggling effects. A perfect real-world example is the black hole at the center of our galaxy, known as Sagittarius A. Astronomers have observed stars and gas clouds whipping around it at unimaginable speeds because of its intense gravitational pull. These observations prove not only the presence of black holes, but their immense influence on their surroundings. As black holes twist space, they also create strange effects on time. This happens because gravity and time are connected. The stronger the gravitational field, the slower time moves near it. Think of it as gravity pulling on time itself, stretching it out like taffy. This phenomenon, known as time dilation, is especially dramatic near black holes. Imagine a clock ticking normally far from a black hole. As it gets closer and closer to the event horizon, the clock slows down until, at the boundary, it essentially freezes in time. From an outside perspective, the closer you get to a black hole, the more time seems to stretch. Here's an analogy. Picture yourself observing an astronaut falling toward a black hole. From your vantage point, the astronaut's movements would slow to an almost complete stop as they approach the event horizon. But for the astronaut, time would feel normal until they cross the event horizon, entering a mystery we can't yet understand. Black holes don't just distort time, they trap it, creating a kind of time prison. The event horizon is where the magic and the terror of a black hole begins. Often referred to as the point of no return, this invisible boundary marks the edge of a black hole's influence. Anything that crosses this line is consumed forever. Not even light, traveling at the fastest speed possible, can escape once it passes the event horizon. As objects move closer to the event horizon, they experience what's known as spaghettification. The intense gravitational pull stretches objects vertically, like pulling on a rubber band, while compressing them horizontally. For anything unlucky enough to get too close to a black hole, it's a grim fate. But what lies beyond the event horizon? At the heart of the black hole is the singularity, a point where density becomes infinite, and the laws of physics as we know them collapse. It's a place of supreme mystery, completely hidden from our sight. Some scientists speculate it could hold the answers to the universe's most profound questions, while others wonder if it's a gateway to another reality entirely. Despite everything we've learned, black holes remain full of cosmic riddles. One of the biggest mysteries concerns the singularity. Is it truly a point of infinite density, or is it something else entirely, a structure we simply haven't found the tools to describe yet? Another enigma is the so-called information paradox. When anything falls into a black hole, it appears that all the information about its past state vanishes. But according to the laws of quantum mechanics, information can't be destroyed. So where does it go? Scientists are hard at work trying to solve this paradox, and the answer could revolutionize our understanding of physics. Then there is the tantalizing theory of wormholes, connections in space-time that might lead to other regions of the universe, or even different dimensions. Could black holes serve as entrances to these theoretical pathways? We don't yet know, but this possibility has captured the imaginations of both scientists and storytellers alike. While they may seem distant and unrelated to everyday life, black holes matter deeply to our understanding of the cosmos. Supermassive black holes, for instance, play a crucial role in shaping galaxies, including our own Milky Way. Their immense gravitational influence holds galaxies together, creating a cosmic order among the stars. Studying black holes also helps us test the limits of our physical theories, from Einstein's general relativity to quantum mechanics. These cosmic mysteries could one day unlock answers to fundamental questions about the universe and our place within it. Ultimately, black holes inspire wonder. They remind us of how vast, strange, and astonishing the universe truly is, stretching far beyond our comprehension but inviting us to explore, question, and dream. As we conclude this journey, one thing is clear. Black holes are more than traps of light and matter. They are windows into the unknown, challenging us to go further and think deeper. What we uncover about them in the future may forever change how we see our cosmos and ourselves.